Ratio, proportion and variation. Variation. Introduction of variation, direct variation, inverse variation and joint variation. Variation. Dear students, we often come across many situations in which one quantity depends on another. Due to this dependence, a change in one quantity brings a change in another correspondent quantity. Variation is a proportion where variables are related by ratios. Let us learn how two correspondent quantities vary in variation. Direct variation. Let x and y are two quantities, and if the value of x vary, the value of y also vary such that the ratio y upon x remains same. Such relation of two quantities is called direct variation. If y varies as x, y is equal to kx, where k is called constant of variation. Y upon x is equal to k. We say that y in direct variation with x, or simply y varies directly as x. Let us see some examples. Suppose a car travels a distance of 60 km in 4 liters of petrol. How much distance will it cover in 8 liters of petrol? From the given example, it is sure that the car travels more distance if numbers of liters of petrol increase. Therefore, distance varies if varies number of liters of petrol. We assume x for petrol in liters and y for distance in kilometer. Therefore, y upon x is equal to k, where k is constant of variation. We have given for x is equal to 4, y is equal to 60. We can find the value of k by putting value of y and x. We get k is equal to 15. Now we have to find out how much distance car can travel if petrol is 8 liters. Put the value of x, y and k in y is equal to kx. We have y is equal to 15 into 8. We get y is equal to 120. Therefore, 120 km distance can travel in 8 liters of petrol. Inverse variation. To understand inverse variation, let us take a very simple example. If we increase the speed, the time taken to cover a given distance decreases. Let us understand inverse variation in another way. Roshan can go to the garden in 4 different ways: by walking, by running, by cycle and by car. Now this table shows the time taken to reach garden according to walking speed. Roshan takes 30 minutes to reach garden if he walk with speed 3 km per hour. As Roshan doubles his speed by running, time reduces to half. As he increases his speed to 3 times by cycling, time decreases to 1/3. Similarly, as he increases his speed to 15 times, time decreases to 1/15. We have seen that time decreases as increase in speed in same ratio. Therefore, we can say that time varies inversely with speed varies, such that the product of both remains same. Let x and y are two quantities. The value of y varies inversely as the value of x varies in the same ratio, such that the value of k remains same. Such relation of two quantities is called inverse variation. Symbolically, y varies inversely as x, written as shown. And the value of k in inverse variation is k is equal to yx. If 15 workers can build a wall in 48 hours, how many workers will be required to do the same work in 30 hours? From the question, we can get time is reduces as number of workers increases to do the same work. Therefore, it is an example of inverse variation. Suppose W represents worker and T represents time. T varies inversely with W varies. That is, T is equal to K by W. Hence, K is equal to T into W. Now to build a wall in 48 hours, 15 workers is required. Therefore, K is equal to 48 into 15. Hence, K is equal to 720. Now, to build same wall in 30 hours, how many workers required? We have K is equal to T into W. Putting value of K and T, we'll get the value of W. Therefore, to build a wall in 30 hours, 24 workers will be required. Joint variation. Dear students, this is rectangle of length 3 cm and breadth 2 cm. We know the area of rectangle is length into breadth. Therefore, area of shown rectangle is 6 cm square. Let us fix the breadth and increase the length from 3 to 4. What happened? Area increased. As we increases the length of rectangle by keeping breadth fixed, area also increases. Here we say that area is directly proportional to length. Same way, if we increases the breadth by keeping length fixed, area increases too. Here we say that area is directly proportional to breadth. But what if we change both the length and breadth? Area of rectangle also changes as both changes and directly proportional to the product of length and breadth. Here we say that area of rectangle varies jointly as its length and breadth. In general, x varies as yz when both y and z varies. We can write this relation as x is equal to k into yz. Hence, k is equal to x by yz. Now, let us solve this example on joint variation. X varies jointly as y and z square, and x is equal to 18 when y is equal to 9 and z is equal to 15. Find z when y is equal to 81 and x is equal to 32. In this example, we have given that x varies jointly as y and z square. Therefore, x is equal to k into yz square, where k is constant. We can write k is equal to x by yz square. Put x is equal to 18, y is equal to 9 and z is equal to 15. From calculation, we get k is equal to 2 by 225. Now for values, y is equal to 81 and x is equal to 32 and k is equal to 2 by 225. We have to find z. Therefore, put these values in equation of joint variation. The equation becomes 32 is equal to 2 by 225 into 81 into z square. By proper calculation, we get z is equal to 20 by 3. In this way, we get the value of z. Summary. In this subtopic, we have seen introduction of variation, direct variation, inverse variation, and joint variation. That is all in this lesson. Hope you all understood this lesson properly. Learning maths is really fun. Keep learning.